Okay, two more problems for you. I'm going to start with the bottom problem first. It says write parametric equations for an ellipse that is centered at 6, 0. It has a vertical major axis that's 9 units long and a minor axis that's 6 units long. Since I'm writing parametric equations, I'm going to use an x and a y. X equals and y equals. The center is 6, 0, so it's going to be 6 plus something, 0 plus something. The x value is the cosine value, so it's going to be a cosine t. And I need to know how far out I am going. Well, this is the minor axis, 6 units long. If the minor axis is 6 units long, the distance from the center to the co-vertex is 3. And so I'm going to get 6 plus 3 cosine t. For y, I'm going to get 0 plus, well, the major axis is 9 units long. Half of 9 is 9 halves, or 4.5 sine t. This will go around forever. If I wanted just to make one loop, I guess I could go 0 is less than or equal to t is less than or equal to 2 pi. The second equation is a little trickier, but not bad at all. It says find parametric equations to define an ellipse where t is time and the motion around the ellipse is counterclockwise. It begins at 0, 3. It passes through 1, 0. It's centered at the origin, and it takes 1 second to complete a revolution. Okay. Because it takes 1 second, we know that the period is equal to 2 pi over b. Okay, in this case, 1 is the period, so b must be 2 pi. So instead of where we normally put the t, now we're going to have to put 2 pi times the t. Okay. So I get x is equal to, and I get y is equal to, it's centered at the origin, so I've got 0 plus and 0 plus. It goes up 1, it goes out 1, and so that's just going to be regular here, cosine 2 pi t. It's going up 3, and so that's going to be 3 times the sine of 2 pi t. However, we've got to make sure that this thing starts at 0, 3. And sometimes you have to do both equations to make sure you find the right spot. I'm going to do both to make sure we're beginning in the right place. I know that if I'm beginning at 0, 3, that the cosine of 2 pi t has to be equal to 0, right? And so where's the cosine? Where's the argument going to be equal to 0? That's when the cosine is pi over 2. So 2 pi t is equal to pi over 2. T is equal to pi over 2 over 2 pi. Pi over 2 times 2 pi. T is equal to 1/4. Checking y to make sure. 3 sine 2 pi t has to be equal to, well, we want the y value to be 3. I'm going to divide both sides by 3. So the sine of 2 pi t has to be equal to 1. So my argument here, the sine of what is equal to 1? Well, pi over 2 again. So we get 2 pi t is equal to pi over 2. Sure enough, t is equal to 1/4. So we have to begin at 1/4. We're going to make a revolution in exactly 1 second. 1 second after 1/4 of a second is 1 1/4, or 5/4 seconds. I think I'm going to give you a bonus problem also. Some people had trouble with this, so let's see if we can prove that the parametric equations x equals e to the t and y is equal to e to the 2t. Let's see if we can prove they make a parabola. It's actually pretty darn easy because e to the 2t is the same thing as e to the t squared, power to a power you multiply. So y is equal to e to the t, which is x, y is x squared, which is clearly a parabola that opens up.